Okay, so here's my lecture on
I'm telling you, when the
3.6.
graph goes into maximum, it's going down.
This is a pretty
I told you it's
challenging
going
topic in the
down,
sense that
okay?
it's got a fair amount of work.
What's with all
It's
this
actually
math stuff? I think I need somebody to help me, man. I need someone to help me.
Using all the knowledge
graph
from
that.
pre-calc for graphing, and on top of that we put calculus stuff as well, so it becomes a fairly long process. So like I'm saying, it's painful, and I thought I'd kind of share this rap with you. It was given to me by Asha Chaudhary about, I think, 5, maybe 6 years ago, and it's really stuck in my mind, and every time I do a graphing exercise I really go to play this. It really brings back memories of doing some really intense problems back in those days. Anyway, I'll let this go on for about another 30 seconds or so, and then to kind of get you in the mood, and then we'll plow into a question that really exhibits all the items that we need to go through in terms of graphing a function.
More than pizza crust. Please take me there. You see a bus. Por favor, miss pre-calculus. I know you got a life. Don't want to give stats.
Okay, so I'm just going to let this go.
Words like quadratic. I have to break the habit.
And let's take a look at what we are supposed to do in this section here. Okay, so the acronym that we're going to use is disarm it, and I must give attributes to Ms. Ford for introducing this to me and coming up with a very catchy term to organize the work. Okay, so disarm it really stands for, when we are trying to draw a graph by hand, to analyze it using these 8 steps. Okay, D stands for domain, I for intercepts for x and y, S for symmetry, A for asymptotes, R for relative. Actually 5 and 6 are really combined. It's RM really is what it stands for, relative, min max, I for inflection, and T for table. Okay, we're going to do this problem here. Okay, x squared minus 2x plus 4 divided by x minus 2, and you need to really organize this in a way that's easy for me to grade and also for you to see. Okay, so part number 1, and this is what I want you to do, is I want you to number the steps. So you get D for domain, and if I take a look at this function here, you can see that x cannot be equal to 2 because the denominator would go to 0. So the domain is minus infinity to 2 union 2 to infinity. Okay, so that's the domain, and then box your answers. Okay? Number 2, I for intercepts. So to get the x-intercept, this is a rational function, so that would happen if the numerator is equal to 0. And obviously, if you try and use a quadratic formula, you can see the discriminant b squared minus 4ac, which is equal to 4 minus 16, is less than 0, so there are no x-intercepts. Okay. Y-intercepts are obtained by putting in x equals 0, and so you get 0 over 4 divided by negative 2, which is negative 2. So that's your y-intercept. Okay. We move on to symmetry, and just as a refresher, remember that symmetry is done by looking at f of minus x, and if it is equal to fx, then it would be even. If it's f minus x is equal to negative fx, then it's odd, and otherwise it's going to be neither. Okay. So if I do f of minus x, okay, in the original function I get x squared plus 2x plus 4 over negative x minus 2. And as you can well see that this is not equal to fx, so it's not even. It is not equal to negative fx, okay, because remember negative fx would look like negative x squared plus 2x minus 4 over negative x minus 2. Okay, this is what negative fx would be. So you can see that this quantity here is not equal to this quantity here. So it's not odd. So therefore it's neither. Okay. So that's symmetry. Moving on to wait a minute, DIS, and then we need to go to asymptotes. Okay. So let's snip one more time. Actually, that's not the way I want it. I want to snip only a part of this. So let's just go this part here. Okay, so that would be number 4 would be A for asymptotes. And I think when you're looking at the domain, we saw clearly that x cannot be equal to 2, so the vertical asymptote is equal to x equals 2. Okay. And then since the degree of the numerator is exactly 1 more than the degree of the denominator, okay, so the degree of the numerator is 2, the degree of the denominator is 1, so the top is exactly 1 more than the bottom. So then there's a slant asymptote, and we need to do x minus 2 is equal to x squared minus 2x plus 4. And so your slant asymptote, SA, is y is equal to x. Again, remember asymptotes are lines, and therefore they have to have equations. So my slant asymptote is y equals x. Okay, next is really R and M together. Okay. Let me get a new snip here, because this is going to be where all the work is. So far it's been all pre-calc stuff. Now it's all calc. Okay. So 5 and 6. All right. So to get the relative min-max, you know, you got to differentiate. So find the derivative. You get keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, which is just 1, all over the bottom squared. Okay. And since we need to find critical numbers of this, let's go ahead and simplify. So the top becomes 2x squared minus 6x plus 4 minus x squared plus 2x minus 4 all over x minus 2 quantity squared. Okay. So that becomes x squared minus 4x all over x minus 2 quantity squared. And so the critical numbers are obtained by setting x squared minus 4x equal to 0, which gives you x times x minus 4 equals 0. So x equals 0 or 4. So these are your critical numbers. Okay, 0 and 4 are critical numbers. Next, we need to figure out whether they are mins or maxes. Now, there are 2 ways of doing this. You could either do the first derivative test, or you could do the second derivative test. Now, we're going to need the second derivative for doing point of inflection. So why don't we just bite the bullet and do the second derivative of this. So remember, the first derivative is this guy here. Okay, I'm going to get a new snip so we can start out from there, and then do the second derivative of that. Okay. So let's go snip this. And so my f prime of x was equal to x squared minus 4x all over x minus 2 quantity squared. Okay. So which gives me f double prime is keep the top, okay, differentiate the bottom. Okay, let me just take a look at this. No, wait a minute. Keep the bottom, x minus 2 quantity squared, differentiate the top, minus keep the top, differentiate the bottom, all over the bottom squared. Okay. And so what I'm going to do is I'm going to simplify this. Okay, this is where all the work is really. So if you look at it, all the work is really algebra level, really. It's not any deep calculus stuff. Okay. So I can simplify this by noticing that this has got a 2 in it, and if I take the 2 out, it looks like x minus 2. So that's why I'm going to go for that. Okay, so it's got to be 2 times x minus 2 cubed. Okay. Minus 2 into x squared minus 4x. There should have been a 2 here. That should have been a 2 then. So minus 2x minus 2 into x squared minus 4x all over x minus 2 to the 4. Okay. Which can now be factored, so I can take this guy and one of this guy and this as a factor. So I get 2x minus 2, leaves me with x minus 2 squared inside, okay, and minus x squared minus 4x all over x minus 2 to the 4. Okay, which then gives me 2 times x minus 2 into x squared minus 4x plus 4 minus x squared plus 4x all over x minus 2 to the 4. And things cancel, so that cancels, and so then this becomes 2 times 4, that's 8 times x minus 2. So one of the x minus 2's cancel there, okay, with the one at the bottom, so you just get 8 at the top all over x minus 2 cubed. So this is my second derivative, okay? And remember, my critical numbers were x is equal to 0 or x equals 4. So I'm going to use a second derivative to test whether these are mins or maxes. So I go f double prime of 0, meaning that I put 0 in here, okay, for x, and that is negative, so that is a Canadian, and so that gives me a max. Okay? And to get the y value, I need to take 0 and plug it in the original equation. That is this, okay? Because remember, the critical number is the number on the original function, okay? So the critical numbers are the x values on the original function. So to get the y values, we obviously have to plug in the x into the original function. So if you do that, then you get a max at 0, negative 2. So you know that's a max. And then if you look at the second critical number, which is 4, okay, and you plug 4 in this equation here, okay, 4x, and that becomes a positive quantity. Okay, so that's a cup, and that gives me a min, and it's at 4. To get the y value, you plug it in the original equation right here, okay, and that should give you a 6. So that's a min. Right? So we've got Rm taken care of, and now we need number 7 would be your point of inflection, okay, and that'd be where f double prime of x equals 0 or undefined. So you can see that it can never be 0, but it can be undefined when x is equal to 2. But 2 is not in the domain, right? Very early on in step 1, we say that the domain is minus infinity to 2, not including 2. Okay, so no POIs. Okay, no POIs. All right. That takes us to step number 8, table. Okay. Now, before we do a table, we need to put down all the features that we've come up so far. So then we know how big a table to make, okay? I mean, what values of x do we really need to put into the table? So let's do, let's just put the features down here, okay? So here's my y-axis, x-axis, okay? Put the scales down, so it's important that you have a scale, obviously, okay? I don't need to tell you this at this level, okay? Graph without any scales is complete and utter bullshit. Okay, the features we have. We have a vertical asymptote at x equals 2. So here's my vertical asymptote. I have a slant asymptote at y equals x, or slant asymptote of y equals x, so that's a straight line like that. I have max at 0, -2, so let's go put those points in there. 0, -2, so that's -1, -2, so I have a max there. Okay. I know there are no x-intercepts. I also know that I have a min at 4, 6, so that's 2, 3, 4, 4, 6. Oh, I don't know. It's somewhere out here. Okay, so there's my min. What else do I know? I got my y-intercept. There are no x-intercepts. And so now I need to make a table. And you do have to make a table. Okay, because that's step number 8. So I want to know what's happening, for example, at x equals -2, x equals -1. I already have a 0. I'd like to know what's happening at 1. And then what else do I need to know? I need to know what's happening at 3. And that should be good enough. Okay, it'll give us an idea as to what's going to happen. So when I do x equals -2, remember I need to put it in the fx equation. Okay, and if you do the plug and chug, your answer should be -3. Plug and chug -1 and you get -2.3. You do a 1 and you get a -3, and you do a 3 and you get a 7. So let's go plot these points down. So -1, -2 is -3, so somewhere out here. -1 is -2.3, so somewhere out there. 1 is -3, so somewhere out there. So it looks like this arm is going to be, so here's my asymptote. Let's just extend this out a little bit. Okay, so that arm is going to look like this. Okay, like that. And then on the other side, I've got 3 is equal to 7. So that's 1, 2, 3. Here's my 4, 6. So 3, 7, let's say, is about here. And I should have really put another point after that. But you know that this is your asymptote right here. So it looks like, and let me just extend these asymptotes so we have enough of that to kind of give us an idea. Okay. So your graph now is this guy here. Okay, and that's how you disarm it. Okay, that's how you disarm it. I really enjoy that little rap tune there. Let's go do it one more time, just to get the feel of it. And every time you are graphing, hopefully this rap song is playing in your mind. Okay.
Okay, class. This is Mr. Johnson, B110. I'm telling you, when the graph goes into maximum, it's going down. What do I tell you? It's going down. Okay?
Man, I don't need all this noise. What's with all this mad stuff? I think I need somebody to help me, man. I need someone to help me, you know, graph that.
Isn't this catchy?
I see you sitting there with your Ticonderoga. Your freshly sharpened pencil made me call you over. You know how boys get down this time in mid-October. I'm thinking about bringing you over so I can watch you
graph that,
right on the chart.
graph that,
Ooh, girl, you're smart.
graph that,
For my exam.
graph that,
Ooh, thank you, ma'am.
graph that,
I'll understand
graph that.
and use your hands.
Okay, hope you have fun. Bye.